The topic is the indefinite integrals review for the summation. We still doing review for the sigma notation. Now theorem. First theorem says let C be a constant, then sum of C from I equal 1 to n is equal nc. So let's do example 10. Example 10 asking us to do the sum from I equal 1 to 122 of 5. What this means, they want us to do 5 plus 5 plus all the way. In other words, the first term will be I equal 1. The last term corresponds to I equal 122. And instead of adding all those numbers, we know our n happens to be 122, and we know our c happens to be 5. So all we need to do is 122 times 5, which is 610. Now let's use the other theorem. The second theorem said sigma of I from I equal 1 to n is equal n times n plus 1 over 2. So let's use it to do example 12. Example 12, they're asking us to find sigma from I equal 1 to 1000 of I. In other words, the first term, if you plug a 1, there'll be 1, right, for I equal 1, plus 2, plus 3, plus blah blah blah, all the way to 1000. So instead of doing all that, we could just use this theorem, and this theorem says my n happens to be what? 1000. So all it says, plug the 1000 here and here. So all it says, this is going to be 1000 times 1000 plus 1 divided by 2, which is 500,000 and 500. Now let's do example 12 using the next theorem. Next theorem says sigma of I squared from 1 to n is equal n plus 1 to n plus 1 over 6. So let's do this one. So for number 12, my n happens to be 20. So I'm doing from 1 to 20. So sigma from I equal 1 to 20 of I squared, instead of doing 1 plus 1 squared plus 2 squared plus 3 squared all the way to 20 squared, instead of adding all that, using this formula make it so easy for me. I know my n is 20, so I'm just gonna plug 20 here, plug 20 here, plug 20 here, and I'm done. So it's 20 plus 1, and then 2 times 20 plus 1, everything divided by 6. In other words, this is going to be 20 times 21 times 41 divided by 6. Now all I need to do is use my calculator, and that would be 2870. It's another theorem. This is sigma of I cubed, which is equal to n plus 1 over 2 squared. So let's do example 13. 13, we're supposed to do sigma from I equal 1 to 100 of I cubed. So instead of doing 1 cube plus 2 cube plus 3 cube all the way to 100 cube, it's going to take us forever. Using the formula, it tells me that my n is 100. So all I need to do, plug 100 here, plug 100 there. So this will be 100 times 100 plus 1, everything over 2, and then square it, which means 100 times 101 divided by 2, and then square it, and that will give me big number, which is 2 5 5 0 2 5 0 2 5 0 0. So actually it's 25,502,500. Now example 4 is a tricky one. They're asking us to do sigma of I times 2i squared minus 5, and we don't have that formula up there, but this is what we can do. We can rewrite this. Let me do it here. Sigma of I equal 1 to 100 of I 2i squared minus 5. First I can distribute the I. So 1 to 100, if you distribute, I get 2i cubed minus 5i. Now also, what I can do, since I don't have sigma of this form of this quantity either, but I know I have a sigma of I cubed and I, what I can do, this is the same thing as the sum of 2i cubed minus the sum of 5i, right, from 1 to 100. From 1 to 100. Now what I'm going to do, I can take the constant outside, both constants. Now this is going to be equal to sigma of I cubed from 1 to 100 minus 5 sigma from 1 to 100 of I. Now I know how to do this. To sigma of I cubed, I'm going to use this formula right here. So plug in n, my n happens to be 100, so plug in 100 there. We already even did it. We did that one, and that's the one we got 25. That's the one we just did, example 13. 25 502 500 minus 5 times. Of course, to do this, sigma of I from 1 to 100, we can use this formula. What is it? We did it for number 11. We can use this one. n plus 1 over 2. So n is 100. So 100 times n plus 100 plus 1, which is 101 over 2, which is equal to 5050. So put it here, 5050, and this is just a number. You can use a calculator. Use a calculator, you'll get 50,979,750. So it's 50,979,750. Now example 15 is really important. That's the one that's the one that we need to learn. That's the one we're going to be using for the indefinite integrals. So now this is going to be from I equal 1 to n. So now you need to pay even more attention. So sigma from I equal 1 to n of I 2i squared minus 5. So same thing we did. We distribute and do all that. So we're gonna get all the way to here, but except that n is equal from I equal 1 to n. So this is going to be equal, actually all the way here. So this is going to be equal to sigma from I equal 1 to n. Same thing we just did for the previous example, except we're not writing 100 for n. I cube minus 5 sigma of I equal 1 to n of I. Now, what we do here, this is going to be equal to 2. Remember, sigma of I equal 1 to n of I cube, it's right here. So it's n plus 1 over 2 squared minus 5. And then sigma of I from 1 equal n, where is it? It's right here. So it's n plus 1 over 2. n plus 1 over 2. Now all we need to do here is rewrite this. So this is going to be equal to, I'm going to square that, so n squared, n plus 1 squared over 2 squared, which is 4, minus 5 over 2, and that would be, I'm going to distribute, I'll get n squared plus n. Let me simplify it a little bit more. I'm going to distribute 2 over 4 simplify the 2, you get 1/2, and then that will be what, n squared, and then this FOIL, n squared plus 2n plus 1 minus 5 over 2 n squared plus n. Which is equal to, since we have the same denominator, let me write it this way. So I'm going to distribute, I'll get n4 plus 2n cubed plus n squared minus 5n squared minus 5n, everything over 2, and then we can simplify it more. This is going to be n4 plus 2n cubed, n squared minus 5n squared is minus 4n squared, and then minus 5n, and then everything over 2. So you need to do example that looks like 15. That will help us. This will help us to do the integrals using limit of the sum. And that's it for the review.